Hello, Anselm Griffin here again with another YouTube tutorial. Today we're featuring Excel and we're doing a linear programming problem using Solver. Now, many of my students have problems even starting these types of problems. Solver problems, because they can't find Solver. So if you have it installed on the data ribbon, there's Solver. But if you don't see it, you have to install it yourself. So how do you do that? File, More, Options, go to Add-ins, go down to the bottom here, Manage Excel Add-ins, Go. And I have them installed already, but for this problem you definitely need the Solver add-in box ticked, but you might as well click all four. And when you do that, if you go to the data ribbon, you will see Solver. Okay. So you have to make sure that Solver is there before you get going. Okay. So here's the problem. I've described, by the way, here I've described how you do it, in text, but I've just done it there. So here's my problem. You have a car park, as shown here, and you can park buses and cars in it. The surface area of the car park is 1,500 meters squared. Car occupies 18 square meters, bus occupies 36 square meters. The attendant or the machine can only process 60 vehicles per day. So what we want to do is, what's the optimum number of cars and buses to be admitted so you maximize the profits? Okay. You might just look at the sheet here. So just in cell A2 is car just typed in, 18 is typed in, and B2, C2 is 36. That's the net contribution for the vehicle. At the moment in D2, I've just put in 1. You could put in 0, you could put any number you want, but I've just put in 1. And then here I have C2 by D2, so the total profit of the cars is 36 by 1. And the total space is obviously D2 by B2, 18 by 1. And it's the same for the bus. 3 by D3 for the total profit. Cars. I suppose I should have vehicles there, just to be precise. And there, the total space is B3 by D3. Now, before we go any further again, the color coding is for a reason. There are 2 constraints. At the moment, what are the 2 constraints? Well, constraint 1 is the total space at cell F4. When you must be less than or equal to 1,500. And also that the total transactions per day has to be a max of 60. So in other words, D4 has to be less than or equal to B8, but we'll get that in a second. Now, unwritten here, but there are some other constraints. The number of cars must be greater than or equal to 0. The number of buses must be greater than or equal to 0. And obviously, although not explicitly stated, you must have an integer number of cars and buses. You can't have a quarter of a bus or 1/8 of a bus or something like that. So here we go, Solver. Now, what are you trying to do? You're trying to make the most profit possible. So that cell, that's what we're trying to do. That's E4 is a maximum. Okay. And what are the 2 cells that determine your profit? They're the number of vehicles, and where are the number of vehicles? That's the number of cars and the number of buses. That's D2 and D3. Okay. The constraints here, let's add a constraint. Just nudge this ever so slightly. So the total space, that is cell F4, is less than or equal to 1500. Click add. What's the next thing? Remember, the attendant can only do 60 a day, so that's D2 less than or equal to B8, the total transactions per day. Click add. Now, the next thing, remember we said the number of cars must be greater than or equal to 0, and the number of buses must be greater than or equal to 0. So where's the number of cars? There. That's greater than or equal to 0. Click add. And the number of buses must be greater than or equal to 0. We have more constraints to add. What's the next constraint? The number of cars must be integer, so that is cell D2. And in here we see int, and int is short for integer. Click add. One more to go. That is the bus, and it too must be integer. And we click OK because that's the last one done. Now there are different methods we can take here, but we're just, that's for advanced stuff here, but we can just leave it as GRG nonlinear, although I suppose if you're into linear programming, that might be a better one, but it doesn't make any difference. We're going to get the same answer. So we click solve. We click OK. And we find here that it works out that we should admit 39 cars, 21 vehicles, and the maximum profit is 2412. Now, I had this done earlier in a Ghost Jordan, and I just have to check my answers here. So if it was non-integer, that value there, the bus would be 20.977. The car would be 39.02, 39.03, 39.023, but we're dealing in the real world and we got the integer values. Just one last thing. I left the solver there as well. I did a screen grab. I might just show the solver again. And there it is there as well. So I sort of have done it twice. So I will post the Excel sheet in the description in the YouTube. Okay, so hope that helps a little, and thanks very much for listening.